Thank you for joining us on episode 2 of the Emerging Technologies group of camps. Today we brought in a guest speaker. We have Gary Moe, and we're going to be discussing RFID technology. Now, leading into this conversation, we were just talking about just general questions as a whole that we'll be addressing today. And with my background specifically in manufacturing engineering, I was just curious, Gary, when people decide to pursue an RFID project, what types of things are the driving factor? Like, what is the low-hanging fruit opportunity for manufacturers and that generally lead to people asking you these kinds of questions?
Yeah, I think, our company, we actually did our first RFID project with Boeing in 1999. So it was, we used some of the microchips that the vets put into pets at the time, and we created this ultra high weight molecular plastic rivet that we put into structural parts. And the biggest, even going back to then, the use case was getting good, accurate data through the manufacturing process and eliminating human intervention and human error. They had a problem of, tags falling off of parts during different manufacturing processes, and, human beings, writing stuff on clipboards and paper and mistyping information. So I think the biggest, one of the biggest benefits again is better visibility, especially of your data from a shop floor standpoint, your asset inventory management, location tracking, work orders, parts on a shop floor.
So with that question in mind, is the RFID following the specific product, or is this a subcomponent that they have built in? Like, are they tagging the product as a whole as it moves through, and how are they using the RFID physically?
Yeah, it's interesting. With our 20 plus years of experience in RFID, we have seen, I would say, especially in the last 3 to 4 years, an increase in the different types of RFID tags out there, and the capabilities now of actually embedding an RFID chip and an antenna into a product label or a work order label. That's been a big advantage, that we can run a label through a thermal transfer printer, integrated even to your shop floor or an SAP system, print out your work order information and also encode the RFID chip in the label. Now, so a great application, and I think this is low-hanging fruit, is putting a work order label on a part or in the pouch of a work order, and it's fairly easy to read. I can use a big label. I get good long read ranges. But there are tags out there that are rugged. We have tags that we're putting on surgical instruments in hospitals and dental instruments that can make it through autoclaving. We work with the military, and we're putting RFID tags on small arms and weapons for tracking, doing audit inventories in the armories, where they can go in with a handheld scanner and read 100 weapons, within a minute or so, and do their inventory versus having to grab each gun, look at the serial number. So that's a huge benefit. And some of these tags now are about half the size of a toothpick, that we epoxy right onto, say, a weapon or a surgical instrument. And typically, the bigger the tag, the longer the read range. So these tags are only, say, 2 to 5 feet of read range, the little toothpick ones, whereas I can get labels that can go on work orders and shipping boxes and pallets now that can read out to almost 30 feet of read range with we're talking passive tag technology without a battery in it. So,
wow. Now, I'm gonna keep asking the questions, so sorry, anybody else feel free to steal from me, but I'm just intrigued. So now, if we're talking about half the size of a toothpick, or just in general, like how expensive would it cost a manufacturer to add a tag to a product with an RFID?
And again, that's a good question. Now, like Nike, I think on some of their Air products, they're embedding RFID tags into their shoes. So we do have manufacturers now. I think some of the tooling manufacturer and are embedding RFID actually into their products, like for tool setup. I know we worked with Boeing early on to embed an RFID tag into their tool holders. So the CNC machine could actually read and make sure it had the right tool holder for the right machining operation. We're kind of drilling out a little area on the tool holder and putting this epoxying a little tag in, and it only needs to be, 6 to 12 inches. But companies, there are tags now that you can embed into your, plastics, and even now into your product labels. So if I am printing out my product label with my part number, model number, and I have what we consider kind of a smart label where I have an RFID chip and an antenna, now I can encode information into the actual label that goes onto the product. And they can track and trace that into shipping and for use, at the customer facility. Boeing and Airbus have had a requirement to put RFID tags on their life limited parts for a few years now. So on the aircraft readiness log parts, there's an RFID tag that, Honeywell and UTC and Goodrich and the benefit to the airlines is when they do their various checks, and they can go through the airplane now with a handheld RFID reader. Delta had a great video, I think, if you go out online, but they have to do a check on all the life vests, underneath the seats. And they'd have mechanics on their hands and knees, looking for expiration dates. And I forgot, it took a couple people, I want to say almost like 8 hours. And now with an RFID tag, they can walk through the plane down the aisle with their handheld reader, just pressing the button, kind of moving their hand around, and they're reading all the tags. And within 2 minutes, they can do a check to make sure all the life vests are within the expiration dates. Same thing like oxygen generators up in the panels. So huge savings. And I think the big thing of RFID over barcode, whether it's data matrix, linear barcode, QR code, is just that whole aspect where I don't need line of sight. I can go in with an RFID reader and even read in through cabinets, wood, pallets, and actually get reads. So it's huge labor savings for your people.
Hey Gary, you mentioned that these are all examples of passive ID tags, right? Could you explain the difference between passive and active? And I'm guessing there's going to be a price difference between them as well, right?
Yeah, so just in general, the passive means there's no battery, so the passive tags are not transmitting any RF energy or information. They need an actual reader, whether it's handheld or there's also fixed readers that you can set up at choke points and doorways and portals in your facility. I think of, going, through the good to go passes, where you're on 405 or you're going over to Gig Harbor across the Narrows Bridge. They have those big readers and, so that's shooting energy into your good to go pass. It absorbs into the antenna and then sends that information back to the reader. So, and for passive, whether it's a handheld, you're sending out RF energy when you press the reader button, and then it responds. Now active, you actually have a battery in the tag. And the big difference is read range, where depending on those little small toothpicks might be a foot range up to even, there's a large tag that the Marines are using that they actually put on trailers and vehicles that we're getting like 75 feet of range off of a passive tag. Now these are like 8 inches wide, by, you know, they're big tags and they cost about $5 a piece. Whereas some of the tags now on the labels are down to, say, you know, 20 cents a piece, you know, even 10 cents and, you know, for work order. But say 1 foot to maybe 20-foot range is pretty typical for passive. Whereas with active, I've got different with the battery in it. I can do low energy Bluetooth. There's ultra wideband frequencies that some companies use, and even Wi-Fi type ranges. But I can get anywhere from 50 to 300 feet of range for my active tag. And they're typically, you know, responding with information, you know, could be even a few times a second, you know, it depends on battery life. But this is where we run into the, you know, what they call RTLS, real-time location tracking. So now we have some projects in hospitals where we're using active tags, and we'll put them on the wheelchairs and the IV pumps and beds. And as they're moving around the hospital, you can see in real time on a map of where the actual part is. It's very valuable, like for nurses that need to find a wheelchair in a hospital, you know, and they're all around. Well, they can just go onto their smartphone, type in wheelchair, hit enter, and it'll show you even by floor level of where all my wheelchairs are, or IV pumps. So in aerospace, a lot of MRO facilities use that for, you know, tracking tooling and jigs, fixtures, tools. It is very valuable for audits, you know, when for government or Boeing owned inventory. You know, you can go to your map grid, you can type in all my tools and see all that. So a lot of benefits there. The active tags are probably more in the $25 to $50 range. So you are paying, you know, higher costs for that. Typically active is going to be for your higher valued assets and equipment and parts that you really need to have a good idea for location, you know, at any time.
Hey, Gary, I wanted to share a small manufacturer that I was visiting. So they were very small. They ran quite a volume of inventory through, but I was surprised as I was walking through. I didn't know anything about RFID. I had no idea the benefits of it, but this is a very small manufacturer, but they did have these sensors above the door. And so I'm asking, well, I haven't seen these kind of sensors before. And they said, oh yeah, this picks up the RFID off of our inventory. And I said, oh, tell me more. And they were early clients of Zemelgo, actually.
Right, yeah.
And so when their inventory comes in, they tag that. And now the inventory moves throughout their small manufacturing facility, but it's all tracked. And then they showed me the software where, and the person who prior to this had been doing everything by paper. So this is kind of back to the use case and the ROI, right?
Right.
It showed me how everything now is done automatically on an app or on the computer, and they know where their inventory is at. And they said because of this, they've eliminated human error, and they haven't run out of inventory because it has pre-selected reorder levels. And the owner said to me, the best part about this is she said, I got my employee back. This employee who was, you know, all day, all night, you know, running, tracking inventory, was now able to do other activities and, you know, made her life easier too.
Sure.
So anyway, that was a small case, you know, but they were sure happy.
Well, we have a large MRO, a very large company that repairs airplane engines and manufactures them. They have an MRO facility with, at any time, maybe 5,000 parts going through work in process. And, you know, on an engine repair, they may have 18 different operations. So they got 18 different work cells, and they have parts movers moving parts all around. But some of these parts are, you know, 2 to 5 month lead time. You know, if you got a special Parker-Hannifin fuel valve for an engine, and it'll happen where they can't find the part, you know, in this couple 100,000 square foot facility. and they'll send an email out to 400 employees at the facility and say, stop what you're doing. We got an aircraft on the ground for the Air Force. We got to get this engine out and we can't find this fuel pump. And everybody will stop and go look throughout their facility for a part. It happens in every industry. And I don't think a lot of companies have, line items typically in their budgets for the year for mistakes and errors and all the wasted hours. Within a hospital, nurses spend, hours a day, from administrative work, but also just looking for parts and misplaced and documenting things. So it's, but yeah, you're right, Kirk. And that's a great, that inventory accuracy, inventory visibility. And, the Zemelgo people have done a really good job with their software of building a really user-friendly, user interfaces that can work on smartphones and tablets and computers. And, they starting to build like trends and data analytics and AI that'll check usage now and make estimates of, hey, you need to order this, you've been ordering this much of that part. And so it's, definitely exciting time for the technology. I might make, it's still not super, you have to know what you're doing. I mean, I know those were some of the questions of the ease of an integration, in our industry. I think what's really, the good thing is, I would say probably 75% of passive RFID has been now in retail. I was, maybe before COVID, I heard some stat that they were going to manufacture over 20 billion RFID chips. And I want to say 12 to 14 were in retail. So, they're embedding labels now in socks and jeans and, different consumer products. And it's one thing, I mean, I can set up a really nice reader at the dock door at Macy's distribution center or Costco and read 500 pairs of jeans coming in the door through a pallet, because there's no metal, there's no liquid. And, with RF technology, metal and liquid is not our friend typically. With, metal, I mean, my RF is going to reflect off of the metal, and with liquid, it absorbs. And like human bodies, we have a lot of liquid in us. So one of the challenges is, if I'm trying to track a tool or a part that I'm carrying through the shop floor, and I've got a reader, say, up on this side, and I'm carrying it here, and my body's blocking that, it's going to block the RF signal. So, when we go out and implement, we have to kind of walk through, do a site survey, and you can't change the physics of RF. The technology keeps getting better, faster, cheaper. We have better chips and, the better read ranges, but there's still just the physics of RF. And we've been out in a factory where they put in an ultrasonic welder, and now I'm getting some weird noise on the frequencies, and there's some of that aspect. But definitely in the last few years, it's definitely, the technology's better, it's more reliable. But I think one of the things, if you're a manufacturing engineer, Ben, and you're expecting to get 99.99, in a big open, on your shop floor, that's probably not realistic. If you're like Intel and and you put readers on your manufacturing line and it's at the same angle and I can read that label, I can do that. But if you're trying to track tools, jigs, fixed, things that are moving around a plant, I can do my best. I can set those sensors up, like you said, Kirk, at choke points, portals, but it's still, you have to use handhelds. We have handhelds that I can set up a Geiger counter mode. I can look for, I have a part missing, I say locate, and it's kind of like, beep, 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 you kind of get within the range of the signal. So there's a lot of different strategies that you need to, to work on, but we have, you know, some engineers that are saying, well, you know, I need 99.99 or this won't work. Well, what are you getting? You know, they're handwriting stuff on pieces of paper. They're doing data errors. Maybe they've got 30–40% of accuracy, and now I can bump them up to the 60 or 80, you know, so it's kind of managing expectations, and there's still a little bit of education required, you know, to do that. But I think we're getting better and better use cases throughout the industry. People are hearing about the technology, and but just to go out and deploy, you know, you really need to look at that and put some thought, do a site survey, kind of do a, you know, in some cases, a little engineering analysis. One thing we always recommend is, you know, do a pilot, do a proof of concept. You know, don't go do your whole factory, you know, and just set up an area where you have some pain points. You know, what's your biggest pain? And then, you know, set up a little pilot, a proof of concept, set up a few readers, handhelds fixed, and then let your people kind of, you know, get to use the technology and really see what it can do and the read ranges, and, you know, to optimize.
So with that, just a question for you in that regard. So if I was a small company and I was looking to do an evaluation like this, how technical do I need to be? Is this more of an IT project? Is this more of an engineering project? And crude ballpark cost of a fair evaluation. What is somebody brand new to this? What should they need to set aside to make sure that they have the right amount of money for a small test? And whose lap does the responsibility fall on?
I think the companies that are successful, you know, the higher level, I think you really need some high level management buy-in on this, you know, whether it's, you know, VP, director, you know, you know, that can see the benefits that will drive that. And then to put together a cross-functional team within your company, because it really does touch all aspects. You know, definitely IT is important, but your operations, your quality control people, your industrial engineers, you know, could be your packaging people, the shipping, receiving of how parts maybe come through, definitely your operations, you know, management people. But it's, you know, I think we have better success when we start the project and we bring all those stakeholders into the room together. Definitely buy-in from management that this is, you know, we've mapped out, we've got some metrics on, you know, ROI in some cases is hard to determine perfectly, but I think people kind of realize how many hours and they're looking for parts and this area is shut down, and really try to consult and ask, well, what is your biggest, you know, pain point? So, but it does, you know, these days, obviously IT security is a big challenge, right? And so I would say as a systems integrator, if we can start off the project, you know, we want to involve IT, but we can set up proof of concept pilot projects, you know, off of an off-network PC, you know, maybe off of a laptop to showcase the technology. If we go right in and tell the IT department we need to load software, you know, whether it's up on the cloud or onto their network, you know, it becomes a much longer, you know, cycle to get anything going. So we do have ways to maybe work, you know, kind of off network, you know, educate them and work on the IT security side of it. I know there were some questions earlier about, you know, well, the thing with passive RFID, it's kind of like a barcode. We really are encoding a license plate number in most cases, a work order number, or, you know, a unique ID in the code that becomes just a pointer to the database. So most cases we're not transmitting proprietary information, you know, even with active tag technology. Maybe we're, you know, we've got a unique ID of the tag that gets associated to a part in the database, and then we're communicating location ID, XY, even GPS outdoor type information. So we need to educate the IT and cybersecurity people that, you know, this isn't proprietary, you know, but obviously with RFID readers now and, you know, handheld and fixed, and even gateways that are reading these active tags, everybody's looking for, you know, is that an open door for a hacker to get into my network? And, you know, so we're always addressing those questions, encryption, and how robust the readers are, you know, to fully implement a system. That's a big issue these days.
So Gary, you've touched on some more advanced integrations that you've done. I've got a personal use case that's very basic. We make tooling for composite parts makers, so layup molds and vacuum trim fixtures, and we're very low volume, highly customized. So it's not a lot to track. And we make our own material. And because of that, we're also going through AS9100 certification. So we're looking at our processes and where we can track things better. And we were looking at using QR codes, labels, laser them onto a tool tag, so that if we were to have some sort of a tool issue, we could scan that back and go back through our files and say, this batch of material came from, you know, from these inputs over here, and we can address that and make sure there's not a more systemic issue. So it sounds like QR or RFID might be a relatively inexpensive way to accomplish the same thing. It's not information I necessarily want my customer to be able to see. We've got our tool tags that have tool numbers and weights and customer names, but we also want kind of embedded information on our tools that is just for our own use if we need to kind of look back and do some investigating. And you also hit on one point earlier. Some of our layup tools, you know, they go into an autoclave at 350 degrees, and it sounds like there's solutions there.
Yeah, we have, you know, and I think barcoding, you know, whether it's linear, QR, or data matrix code, you know, is still a great solution, you know, in certain cases. Now, sometimes, you know, if I go into a room and I've got, or in a tool room or into your area, and, you know, it's sometimes not advantageous to go and read 10 items, right? When I want to just find that one item, you know. Sure. That's where my software has to build in filters and to look for that. But there are some times where, you know, as a barcode scanner with QR, where I can grab that scanner. If I got access to the part, I just scan it. I know I got that part, right? You know, I could be at a workstation, I'm trying to read an RFID tag, and for whatever reason, I'm reading the next bench. So I got to be careful, you know, with, especially out in a facility that's got a lot of metal, because I'm getting reflections and scatter and things like that. So, and I would say, you know, we typically see in an organization and in a manufacturer, or, you know, even, you know, hospitals, that we kind of call it the hybrid solution. But it's probably not one solution will do all, you know, where we're passive, and, you know, barcode is still good in certain cases, and active tags. Now, you know, active's not a good fit, but it's a good fit for some. So a lot of the software solutions out there now are, you know, handle that hybrid type solution where they'll integrate with active, passive, and barcode. And that's typically what you want to look for, because in most cases, it's not going to be just a one solution that fits every use case within your company.
So it sounds a lot like there's kind of three cost considerations when you're implementing something like this. The tags themselves are relatively inexpensive, particularly if you're talking about higher value items, if you're not doing millions of widgets. Then there's the readers themselves and the software that kind of works to tie everything together. Is that accurate?
Correct. And, you know, we've seen, you know, it is getting better now, but, you know, a few years ago, one of the big costs of a system within a company is just the infrastructure cost to, run power drops for the readers, and do the mounting, and a lot of them required Ethernet. There are Wi-Fi readers out, and the Wi-Fi is getting better in certain facilities, but a lot of times, Ethernet or power over or PoE type connections are better. So you have to really look at that, that cost, just the facilities cost. And the bigger the company, sometimes, we had one very large company, I think they needed 4 different contractors to mount, a reader, right? They had to do the power drop, they had to do the Ethernet, they had another contractor that actually physically mounted it. And then they had another contractor that connected everything together. So, it was, $3,000 to $5,000 per portal, and it wasn't the hardware of the reader. So that's where sometimes the active tag technology, could be, say, $40 to $50 for a tag, but if I can, I have 100 to 300 feet of read range, and say I only need to install 20 readers, gateway readers, to cover a big plant versus 100 passive readers, that's a huge, when you look at that facilities cost to run all that wiring, cabling, that's sometimes where active tags make sense. And there might be passive that makes, where parts don't move, you've got a storage area, so you kind of got to go into a customer, kind of talk about that. See, that's where coming on site, seeing a site survey, just learning more about your, the processes and the parts and the pain factor, a lot of, especially in our industry, obviously annual wall-to-wall inventories are a big deal. That's where this technology can really, really help. And just that inventory accuracy, visibility, tracking work orders on your shop floor is knowing where your work orders are, what the status is, where the department, tracking timing. So there's a lot of good benefits to manufacturing an organization.
So if somebody has a question for you, you're the expert on RFID, you do the integrations. How do they get a hold of you? How do they find more out and learn more about RFID?
Sure. We consult and talk to various people all the time. We have a lot of information on our website. We're based out of Mukilteo in the area here. Our website is www.id-integration.com. We're on LinkedIn, and they can get through to us that way. I'm members of camps and can track us down, but we're happy to have that discussion and just kind of talk through the use cases and if it's a good fit. And I think one thing that makes us unique, with our 20+ years of experience is, but also we're not just exclusive to one manufacturer or one technology. So we're, as a systems integrator, we have a lot of expertise in barcode, direct part marking, laser etching. We've done 20 years of work with the Department of Defense and Boeing and the military side of it with their UID policy, and the commercial Boeing and Airbus RFID requirements. And now shop floor, we're doing a lot of work now in healthcare, in hospitals. And I think it all comes down to the automated data capture. We just want to, get humans and beings not having to track data. So, and make errors and things like that. So we have a lot of we'll share our honest opinion if it's a good fit, and we have no motivation to just steer someone to one side or the other. And it does, like Jacob was mentioning, cost and versus benefit. And again, that whole hybrid solution, I think we're seeing more and more of that. And with the costs and the performance of passive becoming better now, we're feeling more confident on solutions that integrate passive, especially in our manufacturing environments.
I want to thank everybody for being here, because this is part of our emerging technologies innovation group.